Jake, you asked me about this graph, how it goes on and on forever without actually reaching the x-axis or the y-axis. Oh, that's not very good, is it? I've done this, I started this a while ago, this talk, and Karen used the F word, and then I had to start again and the camera went wrong. So anyway, so you can't really release a video with the F word in. She's laughing, she thinks it's funny. Anyway, so what I want to do is talk a little bit about this, and but before I do, I think the thing to do is to just first of all talk about how to plot a graph. You will remember that a little while ago I plotted a couple of graphs. One was, I think, y equals x, which looks like that. And maybe 1 minus x, y equals minus x, and perhaps y equals minus x plus 1. And I did that, so you can refer back to that. But what I'm going to do here now is plot a couple of examples. One is y equals x squared, and the other one I've prepared earlier is y equals x squared divided by 2 plus x plus 1. Okay, this is this one is sort of easy looking and fairly obvious, but this one, when I plot this, you'll see how the difference between these two moves the graph, or changes the graph, or transforms the graph. So, start off with this one. I'll need this space, so let's just have y equals x squared. And for that, I'm going to first of all write some numbers for x. Start with minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Yeah, that's it. And then, so x squared, y equals x squared, will be plus 9, plus 4. We talked about how the square of a negative number is positive. Plus 1, 0, plus 1, plus 4, plus 9. The next one would actually be plus 16. So, plotting this. So upwards and downwards, we want this to go from at least up to plus 9, up to plus 9. No, that's a bit of a silly thing I did. Knowing that it ranges between 0 and plus 9, or let's put the axis down here. Right, the y-axis, the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So what I'm going to do, I'm actually going to squeeze in the -4 plus 16 x and y equals x squared. I'm going to squeeze that in just to, so here's -1, -2, etc. So 1, -1, -2, -3, -4, -5. Doesn't range over very far over x, this. Okay, I'll tell you what I'll do then. I'm going to make this scale different. Yeah? I'm going to make this scale bigger. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, right. -4. Let's put -1, -2, -3, -4. Plus 1, plus 2, plus 3, plus 4. By the way, you will do this at school, I'm sure. Usually what I talk about are things that you probably won't do at school, but which are quite interesting. Yeah, you will do this at school. At GCSE level, I think. Pretty sure of that. So, when x equals -4, y equals -16, which was this one, if you remember. So it comes here somewhere. Let me have a look. Comes there. So there's a point at there. On y equals x squared, there is a point there. One, 2, 3, 4, 5, 6, 7, 8, 9. -3 aligns, well, y equals 3 squared is 9, plus 9. It comes there. Right. For -2, it's, I mean, it looks like a straight line, but it's actually not. -1 squared is +1. Naught squared is 0. Then on the positive side, we've got the same values of y. And this goes up then to 5 up to 25, etc. So I'm going to draw this in now, assuming, well, you could prove that all these points actually, all the points that are not drawn are actually on a line, and that they are there. They are on that line. shape of this curve, y equals x squared, is called a parabola. And as a matter of interest, if you have a cone, say this is a cone, a solid cone, right? And you cut the cone like that, so that this cut is parallel with the edge there, but it's not really an edge, the surface there, and then you look in this direction. If you take this bit away and look in this direction, the shape you will see will be a parabola. That's just an interesting point. It's called a conic section. You can cut a cone there, that'll be an ellipse. You can cut it across here. You look down and the cut there the surface of the cut would be a circle. And then there's another one which is further out, more of a vertical angle than the parabola, and this is called a hyperbola. Never mind about that. But anyway, so that's the first one I wanted to show you. X squared. Now the other one. The other one was y equals x squared over 2 plus, I think, x plus 1. I think that was it. That's it, yes. And, so the numbers. We're going to plot it between -4 and +4. Later on I'll show you, although I'm doing this sort of mechanically by hand, I'll show you later how to easily do this, how to use GeoGebra to do these curves. You just type in the formula and it makes it. It calculates every point, of course. Well, can it calculate every point? But so that you can't, it looks like a continuous line. So that means that x squared over 2, that's plus x squared over 2, is plus 8 plus 4.5 for that one, plus 2, what? Yeah, plus 2, plus a half, 0, plus a half, plus 2, plus 4.5, and plus 8. Then the x, let's add in an x here. That's -4, -3, -2, -1, 0, plus 1, plus 2, plus 3, plus 4. And then there's the 1. We're going to add these up in a minute. So that's plus x and plus 1. Yeah, they're all positive. 1 plus 1 plus 1 plus 1 plus, terrible. Plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. And so y equal to x squared over 2 plus x plus 1 is what we find now. 8. Minus 4 is 4, plus 1 is 5. Plus 5. Plus 2. Is that right? Just 2.5 actually. Oh, that should be a plus. So that's now a 1. Yeah. This is plus a half, I think, by the looks. Yeah, that's what I've got before. Plus 1. 2.5. Is that right? Yeah. Plus 5. Plus 8.5. Yeah. And the next one is, looks like plus 13. So, from here to here, well, from here outwards, from centred on this, on minus 1 here, you can see that there's symmetry. Plus 1, plus 2.5, plus 5. So plotting this is actually going to all again be above the x-axis. So I can put the x-axis down here. What's that? Oh, that's the... One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Minus 1, minus 2. One, 2, 3, 4, 5. That's not very good. Should be a little bit further out. Not good enough, Steve. I'm going to make the scale a bit wider again. Okay. So, 1, 2, 3, 4. When x is minus 4, y equals 5. 1, 2, 3, 4, 5. So it's there somewhere. One, 2, 3, 4, 5. No, 4, yeah, 4. Yep. When x equals minus 3, 2.5. Y equals 2.5. So it's there. When x equals minus 2, 1. When x equals 0 plus 1. Wait a minute. Really? That's wrong. When x equals minus 2, This is all, I've gone wrong, entirely wrong. When x is equal to minus 3, it's 2.5. Yeah, that's it there. When x equals minus 2, it's 1. Really? Yeah. So that would be there. When x equals minus 1, it's a half. So that would be there. I hope you can see this. You can just about. When x equals 0, 1. So it's going back up again. When x equals plus 1, 2.5. When x equals 2, 5. When x equals 3, 8.5. 1, 2, 3, 4, 5, 6, 7, 8.5. When x equals plus 4, when x equals plus 4, what? 13. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. So without calculating, so it doesn't go down to 0. This thing misses 0 and it goes up here. This parabola. And we can see that if we to plot x equals 5, it would be up here somewhere. About there probably. And if we'd gone down here somewhere, it would be symmetrical up to there as well. Be the same. But it's moved it to the left and up a little bit. These two and the half have moved it up by a half. Yeah, by half, and moved it over to the left by 1. I'll talk about the y equals 1 over x in the next video.